Biodiesel production plant. Biodiesel is a sustainable material and renewable sources. It can be used as alternative fuel.
The process of this plant can be divided into two parts. The first part is esterification and transesterification of the raw material to biodiesel. The raw material used in this process is cooking oil, grease trap oil, palm oil fatty acid distillate and tallow. Then, it changed into methyl ester via esterification. In order to produce biodiesel, methyl ester is mixed with methanol. The second part of the process is byproduct preparation. For methyl ester, it contains certain amounts of methanol, catalyst mainly in form of soaps and water. It can be removed by several washing steps. For example, the aqueous phase is discharged to the byproduct preparation line. After the last washing step, the byproduct contains low volatile high boiling contaminants as well as volatile substances such as water and methanol. For volatile substance, it will be removed in the flash column or known as deglycer and being transferred to the byproduct preparation line. The distillate represents the high-quality methyl ester and is transferred to the biodiesel quality tank, and later, to the biodiesel storage tanks. The low volatile high boiling substances are removed in the distillation unit. Low volatile high boiling substances, namely bioheating oil, are discharged to a storage tank. It can be further used as heating oil for an oil burner and will be used to provide process heat in the plant. This is the site location of the biodiesel plant and it would be in Gebang Industrial Area in Pahang. The process starts with the steam condensate, waste cooking oil, WCO, trap grease oil, and animal fats are fed to the purifier and before entered the esterification and transesterification process. The process continue with the high content of free fatty acids which includes palm oil fatty acids and grease trap oil are directly transferred into methyl ester by esterification using high pressure, high temperature reaction conditions without catalyst. The certain amount of free fatty acids as well as fatty acids recycled from the byproduct acidification from glycerin FFA separator, and oil phase from purifier esterified by using methanol under acidic condition and ambient pressure in a batch process. Catalyst is used in transesterification reaction and possible under moderate temperature and normal pressure. Catalyst used is potassium hydroxide and methanol. Then, the process continues with methyl ester benzene recovery process. In this process, methylbenzene phase contains certain amount of methanol, catalyst, and water. The catalyst is removed by using several washing steps. The excess methanol is recycled back to the transesterification process. After the last washing step, methyl ester that contain of low and high volatile of substances such as water and methanol are separated by using flash drum, deglycer, and distillation unit. The volatile substances from deglycer are transferred to the byproduct preparation line. Low and high boiling substances, namely bioheating oil, are discharged to a storage tank and will be used as heating oil for an oil burner. Next, glycerin phase neutralizer process is used. In this process, glycerin from transesterification and the aqueous phase of the methyl ester purification are processed together in the acidification vessel. Potassium hydroxide and the potassium soaps are transformed with sulfuric acid to potassium sulfate, glycerin phase, and fatty acid phase in this process. In fertilizer separator and glycerin fast separator, the generated potassium sulfate is discharged via a screw conveyor to a container as pasty fertilizer. Meanwhile, in crude glycerin neutralizer, the acidic glycerin phase from the tricanter is neutralized with the basic catalyst in the neutralization tank and the generated potassium sulfate is filtered off and discharged back to acidification tank. Lastly, in the process of glycerin demethanolizing and dewatering, the filtered neutralized glycerin phase is distilled. In the column methanol and water are separated from the glycerin and the second column separates water and methanol. Crude glycerin, 80%, is discharged to the storage tank. For the process of wastewater treatment, pretreatment process is needed. Wastewater from the production site will be flowing to an influent pit by gravity for collection to remove big solid particles and then will be pumped to an oil-water separator. The oil-water separator is used for free oil removal and the wastewater will flow into the buffer tank by gravity after wastewater undergoes oil removal. The buffer tank is to equalize water quality and flow fluctuation. After the wastewater is equalized in the buffer tank, it will be pumped to the dissolved air flotation unit, DAF, from buffer tank for further removing total suspended solids, TSS, and oil in wastewater. Next, the process continues with anaerobic treatment. The wastewater will be treated anaerobically in a two-stage anaerobic process. In the first stage, pre-acidification tank, the wastewater is partly pre-acidified. In the second stage, IC reactor, the organic pollutants of the wastewater are converted into the biogas. After anaerobic treatment, the wastewater will flow to an activated sludge system for further removal of remained biodegradable chemical oxygen demand, COD. Activated sludge system consists of an aeration tank and a secondary clarifier. In the IC reactor the byproduct, namely the biogas, is produced. In biogas treatment, the amount of the biogas produced depends on the COD load applied to the IC reactors. The higher the COD load is, the higher the biogas production will be. The biogas will be collected in the degassing tank on top of the IC reactor for gas-water separation. The IC reactor and the biogas treatment facilities are closed system. The biogas is burnt either in the process boiler system or the flare without emission to surroundings. The process continues with off-gas treatment. Odorous components like hydrogen sulfide, H2S, may be released from the wastewater treatment plant, WWTP. The off-gas will be sent to a scrubber for odor removal. The last step for the process is sludge treatment. Sludge will be collected from the secondary clarifier and the DAF. The sludge discharged from secondary clarifier and the DAF has low dry matter content. In order to increase the dry matter content of the sludge has to be further dewatered by mechanical dewatering equipment. For sizing of equipment, settling tank design capacity of this plant would be 2,500 gallons with carbon steel material. The radius of the tank is 0.93 meters and the height of the tank is 3.5 meters. The design capacity of the biodiesel plant is 100,000 tons per year and cost for wastewater treatment plant is $0.004969 per gallon. The total amount needed for wastewater treatment is Rm 67,732.78. The environmental impact assessment, EIA, of this plant is divided into two phases. The first phase is the construction phase. For the construction phase, possible impact on the environment are dust, traffic, land and marine, liquid effluents, discharges or contaminated runoff, generation of waste, disruption of water movement and marine ecology. Meanwhile, the second phase is the operation phase. The possible impact on the environment are gaseous emissions, odor, nighttime operations, traffic, land and marine, liquid effluents, discharges or contaminated runoff, generation of waste, hazard to life and cumulative impacts. In construction phase of air quality aspect, no major work required for site formation and minimal dust generated as tanks and equipments will be assembled on site. Construction of the plant will involve equipment and noise produced during construction will be minimal. Water quality impact in construction phase involves minor marine works. No soil or sediment removal would be carried out. All the construction and demolition materials will be segregated on-site and stored for disposal. Chemical waste will be sent to Chemical Waste Treatment Center. In environmental protection measure, all debris and materials will be covered or stored in a sheltered debris collection area and dust control measures will be implemented. Meanwhile, in operation phase, air quality impacts due to emission in the plant will be predicted using air dispersion model. GTW will be delivered by sealed road tankers and discharged directly from the tanker to storage tanks and closed system to prevent odor. Unloading stations will be enclosed and fitted with ventilation and air scrubbing system. Noise generated from the plant and equipment will be limited. Water quality impact in operation phase involves all wastewaters generated will be collected and treated at wastewater treatment plant before being discharged to any drains or river. An emergency response plan, ERP, will be developed to impose actions to be taken during emergency. For the waste aspect, all the solid waste produced will undergo treatment process before being disposed at landfill. Potential land contamination may arise when there is any spillage of chemicals. Biodiesel is biodegradable and the environmental impact due to spillage will be much lower compared to petroleum diesel. In environmental protection measure aspect, proven technologies and environmental protection measures have been adopted for the design and operation of the proposed biodiesel plant. The environmental assessment shows that the operation of the biodiesel plant will not cause adverse environmental impacts and unacceptable hazard to life.